Right, we're looking here at defining complex numbers. And it's interesting, the author defines them in what I would say is an atypical way, as opposed to the typical way. And so they define them as an ordered pair, which is kind of nice in that we often graph them as a complex number as an ordered pair. And so they say the complex numbers are a set, okay, C, and they use a colon equals as a definition here. And you've got this ordered pair, X and Y, where X and Y are both real numbers. So that just looks like the Cartesian plane at that point, right? But they say they're a set, C, but here we're going to give a definition of addition. So equipped with addition. Now the addition, as you look at it here, looks pretty normal. So, you know, if I take an XY plus some AB, I get what you would think you would get, I guess, X plus A and then Y plus B. Okay, so that's addition, but now here's the multiplication, and it looks really strange. And so if I take an element xy and I multiply it by AB, now probably what you'd like to get is ax comma by, but that's not at all what you get, and it's xa minus yb, and then whoops, parenthesis around that, and then xb plus ya. So what the heck's going on there? Well, you know, so this looks like very strange multiplication. The addition looks fine. But now let's define complex numbers in a slightly different way. So first of all, let's say that we're going to define I such that I squared is equal to -1. Okay, so that's very strange. But now our complex number is, we often use a z, x plus iy. Okay, so x plus iy, where x and y are elements of the real numbers. Oh, so you see this is an ordered pair. So if we come back up here, we've got an x and a y. X and y are elements of the real number. X came first, then y in that case. But here, you could call this an ordered pair as well, because typically we would write it as x and then plus iy as opposed to iy plus x. Yeah, you could write it that way. But it still really, even then, defines an order because we've got x that isn't multiplied by I, and then y that is. Okay, so there's your ordered pair, x and y. So that's so far, this idea of complex number that we've seen before um, in high school algebra, something like that. Um, you could fit it this way. Now, what happens if I add z plus w? So that's an x plus iy plus an a plus ib. Well, here, if we add this, we get, it seems reasonable that I would take x plus a and then plus I times, because we're saying times, I just factor out the I and I get y plus b. But again, you see, that's just the addition we had back here, that we had an xy and an ab, and then we made that x plus a and then y plus b. And that's what we have here, an x plus a and a y plus b in those. So, the addition this way is the same. And now if I take z times w, well, that would be an x plus iy times an a plus ib. Now, if we just multiply that in the usual fashion, we'll get, now I don't remember if back here I wrote xa, okay. So I would get xa plus iya plus xib plus iyib. Now, if I write that as xa plus, and take this term here, and that's I squared yb, and then plus those two terms factor out the I, and I get I times ya plus xb. Now, I squared, though, remember, I squared is defined such that I squared is -1. And so this is xa minus yb, and then plus I ya plus xb. And so you see, if we go back to our ordered pair definition of multiplication, there's the xa minus yb. That's what we have here, xa minus yb. And then we have the xb plus ya. I guess I wrote that in the opposite order, xb there plus ya, but same thing. And so you see, you could, without ever introducing this idea of I, the square root of -1, or I squared equals -1, without ever introducing that, I can introduce this notion of complex variables. And so it's just an interesting thing that this author does, is introduce the definition of complex variables in terms of an ordered pair. But again, that I think makes a lot of sense in many ways, because we end up graphing complex numbers as ordered pairs. And we'll see that in future work. So with that, we'll end this video and then go on to some of the properties.